Hello everybody, thanks for coming to our presentation, which is about evaluation of the different deep learning models for mapping urban floodwater at large scale. I am Zhao, a PhD student from Luxembourg Institute of Science and Technology, which is also co-supervised by Vienna University of Technology. So why we need to do the flood mapping? As you may know, the flood is one of the most frequent and costly natural disasters all over the world. As you can see here, one paper has been reported that more and more people has been exposed to the floods, and also it has been reported that only in 3 months ago, the July 2021, over 920 people has been killed in floods and landslides, and also about 124 flood events affected 385 locations in more than 20 countries has been reported. So in order to improve our capacity to understand, monitor, and predict flood risk at large scale, there is a need to advance SAR-based mapping for floods within urban settlements. However, in this stage, urban flood mapping is still challenging due to the complex environment of the urban areas, because usually urban areas is a mixture of the vegetation, buildings, and bar soils. Standing water in built-up areas may lead to a combination of the different types of backscatter mechanism, depending on the strength of the double bounce effect between the floodwater and the building facade. However, based on the literature review and the previous experiments, we can notice that besides the SAR intensity, interferometric coherence is available for improving flood detection in urbanized areas. For example, as you can see here in this figure, in the first 2 columns, there is a flooded bar soils and open areas, but only in the column A, we can see there is a big changes in the intensity, but when it comes to the column B, which has the flooded tarmacs, the changes of the intensity is not that obvious. When it comes to the flooded buildings, in column C and column D, it is even more clearly that the changes of the intensity is various, while the decrease of the coherence is able to identify the flooded building areas. Besides the traditional model-based approaches, the deep learning method learns how to classify the presence of floodwater from data without the prior assumptions on land cover classes. Thus, in this study, we will try to use SAR intensities, interferometric coherence acquired in VV and VH polarizations in pre-flood events and post-flood events, and use some different deep learning methods. And in the deep learning fields, since the supervised deep learning also requires a large amount of the training data set, which is not available in reality, so in this case, the attention mechanism has been proposed in order to help the model to select the robust features, and which can be divided into 2 categories. The first one is the self-attention module, which means that the self-attention is able to compute the attention weights only based on the input features. For example, we'll have the channel attention modules and the convolutional block attention module, which is composed of the channel attention module and the spatial attention modules. Then we have the cross attention module, which breeds the attention across different data. For example, they try to combine the hyperspectral images and the LiDAR data all together in order to do the image classifications, and also they provide the attention gate, which is help to rescale the input data by the attention gate. In this study, we will try to use the UNet, which is designed for biomedical image segmentations with a limited training dataset. And in this case, we will try to use the channel attention module, attention gate module, and also the CPAM attention module all together with a UNet in order to understanding the large-scale urban flood mapping using SAR data. So in this study, we will test our deep learning model in 4 different flood cases, and based on these flood cases, we will select 2 small regions of interest from the Houston flood and Milwaukee flood as a testing as a training and validation of the models, and the rest areas will be used for testing. Here is a training data set. We selected the red areas is FU, which is flooded urban areas. The blue areas is F4, which is the flooded open areas, while the yellow pixels represent the non-flooded areas. So here are the results for the Houston cases. As you can see, the first images is a reference, while the other four are flood maps generated by the UNet, UNet with a channel attention, UNet with a tension gate, and UNet with a CPAM attention module. So it is quite clear that the UNet with a channel attention has the best result since it has the less over detections for flooded urban areas. The similar phenomena can be also observed in Japan study set. As you can see that the UNet with the channel attention generated flood map with less over detection of the flooded urban areas. When it comes to the Beta cases, it is even more clear that even though the UNet with the channel attention has the less over detection, but still all of these four deep learning methods cannot provide satisfying flood maps since the over detection of the flooded urban exists. When it comes to the last dataset, which is about Somalia cases, it is clear that the UNet with the channel tension do not have over detection in flooded urban areas, but still the over detection of the flooded open areas exist. Let's come to the conclusion. Based on our study, it is quite clear that the channel information is quite important, as the UNet with the channel attention provides the best result in this study. However, UNet with current available attention mechanism does not provide satisfying results for large-scale urban flood mapping because of the limited training dataset we used, and also even with this kind of limited training dataset, the imbalance of the data exists. Also, comparing with the biometrical image data with a single band, our SAR data has 8 bands. That means the complexity of the input data has been increased, that the available deep learning model is unable to deal with these problems in large-scale urban flood mapping. That, in this case, we have to say that new deep learning structures is needed. Here are some basic information about myself because now I am a PhD student focusing on large-scale flood mapping using SAR data, but I'm going to finish my PhD at the end of this year, so I'm looking for postdoc or research positions in the future. My research interests include deep learning, urban flood mapping, SAR data analysis, large-scale analysis. So here I put the QR code of my LinkedIn and ResearchGate, and if you are interested, you can reach to me by these two websites. Also, I put the QR code of two published papers. One is about large-scale flood mapping using InVisit data, and the other is about deriving exclusion map from SIP and SAR time series data in support to the floodwater mapping. Please feel free to contact me if you have any open positions or you are interested in my research. Thanks for your attention.